Alright, so we're going to look at the unit circle and kind of create it from scratch. So here we have a circle of radius of 1, and we're going to also use the space down here to create the sine and cosine curve from what we have with the unit circle. So let's start out by remembering that every circle has 360 degrees, and that the unit circle specifically has a distance around it, or a circumference of 2 pi, and we're calling those radians, but most of you guys just need to remember that it's a distance around the circle. So, and if you picture someone taking a walk around this circle, we say that if they walk counterclockwise, like the direction my cursor is moving right now, it is the positive direction. So we're going to start at 0 radians, and then remember that half the circle is pi, and going back to the beginning of the circle, we also call that 2 pi to get all the way around. So we're going to count by halves of pi first. So if I take this top half of the circle and start walking, here I get pi over 2, or 1/2 pi. Keep going down. It's 1 pi, or 2 pi over 2. Down at the bottom we have 3 pi over 2. And then back at the beginning we would have 4 pi over 2, which is the same as 2 pi. So we can do this idea to create several other types of fractions. So let's count in fourths at the beginning. So we're going to go, so again we have pi over here, 1 pi over here, so I'm going to count 1/4 pi, pi over 4. At the top that would be 2/4 pi, same as pi over 2. And we have 3 pi over 4, 4 pi over 4. And then we continue on the bottom half. I'm just going to add a fourth every time. 5 pi over 4. Down at the bottom, 6 pi over 4. 7 pi over 4. And then back to the beginning, 8 pi over 4, or 2 pi. Then we're going to do sixths. So I'll draw a dot here for 1/6 of pi. So again, we're dividing the top half of the circle into 6 pieces now. So 1, 2, 3, 4, 5, and 6. So this is going to be 1/6 of pi going up. 2/6 of pi. 2/6 is the same as 1/3. 3/6 at the top, same as 1/2. 4/6, or 2/3. So 2 pi over 3. And then 5/6 pi down here. 5 pi over 6. And then again we can do the same thing with the bottom half of the circle, just continuing on, counting by 6. So 6/6 is at pi, 7 pi over 6 here, 8/6 or 4/3 down near the bottom, 9/6, same as 3/2, 10/6 or 5/3. And then finally up here we have 11/6 pi, or 11 pi over 6. And then back up at the top we'd have 12/6 pi. Alright, so what you guys can see is that down here on our x-axis of this graph we also have all these radian measures. So I'm just going to write radians. Radians. Down at the bottom here, and we'll continue on. So the next thing we want to know then is what happens to our coordinates as we go around the unit circle. Okay, so there are some simple ones. Let's draw those in first. We got a simple one at 1, 0 there, and then at the top we have 0, +1. The y-coordinate is 1, the x-coordinate is 0. Over at pi we have x is -1, y is 0. And then down at the bottom at 3 pi over 2 we have x is 0 again, and y is -1. Okay, so remembering our little trick, if I start making a bunch of ordered pairs as we go up, kind of going to run out of space a little bit here. But the trick on these is to make fractions over 2 out of all of them. Alright, and then we're going to look at going up. You're going to go 1, 2, 3, and then come back down 1, 2, 3. And then you're going to put a square root over everything. So square root of 1 is 1, so we're going to leave that, but you got a square root of 3, square root of 2, square root of 2, and a square root of 3, and then you'd have a square root of 1. So what this does, this is a little trick for creating all the coordinates on the unit circle, and remembering, for example, that right here we have, this is at pi over 3, you have an x coordinate of 1/2, and a y coordinate of square root of 3 over 2, and that just comes from our 30, 60, 90 degree triangle. Okay, and every ordered pair here is equal to the cosine of the angle, the cosine of the radian measure. So this is the cosine of pi over 3, and then the y coordinate is the sine of that radian measure, or sine of pi over 3. So that's another way to write that. So if you type it into your calculator, cosine of pi over 3, you're going to get 0.5 or 1/2. Okay? If you put sine of pi over 3, you're going to get a decimal, because square root of 3 over 2 is irrational, and it'll just give you a bunch of long decimals that don't make a lot of sense. So you want to keep it in terms of square root of 3, keep it in radical form. So when we do this, you can do it all the way around now. Okay? So you can go and do the same thing for the other quadrants. The only difference is that the sign changes. So let's create quadrant 2 here. I'm going to again make my ordered pairs. So I have an x and a y coordinate. I'll do 2 pi over 3 out here. Alright, so again we put everything over 2. So a bunch of halves, basically. And then if you look, our trick was to go 1, 2, 3 for the y coordinate, and then count down for the x. 1, 2, 3. And then put those square roots over the top. Square root of 2, square root of 2, square root of 3 up here. Now the difference between quadrant 1, everything was positive, and quadrant 2, if we're in quadrant 2 over here, x becomes negative. Our x coordinate becomes negative, but y stays positive. So then I just have to go through, and every x coordinate, I'm just going to put a negative sign in front of it. And then we can go ahead and do the same things for the other 2 quadrants. Quadrant 3, x is still negative, and y is also negative now. So here's the 3 more. I'll show you guys one more time. Make halves, 2, 2, 2, couple more halves here. Alright, and then again we're going to count with our y's. We're going to go 1, 2, 3 on the way down, and then 1, 2, 3 to count back up to our x-axis. And now everything, we'll put those square roots over first again, don't forget those. And now because we're in quadrant 3, x and y have minus signs in front of them. So everything in quadrant 3 is negative, because in quadrant 3 everything is negative. Alright, and let's wrap it up then with quadrant 4. So I'll draw in our coordinates again. Remembering to make halves out of everything. And then again in quadrant 4 now, x is going to be positive again, but y will still be negative. So we'll start up by our x-axis, and you've got 1, 2, 3 on the way down, and then count back up 1, 2, 3. Go ahead and put in your square roots. Square root of 3, square root of 2, square root of 2, and a square root of 3 there. And then now our y coordinate is negative, and our x coordinate is positive, because we are in quadrant 4. So now we have a complete unit circle with all of the radian measures. We start out by creating the radian measures, and then we filled out the the coordinates of each point, remembering that the cosine of the radian measure is the same as the x coordinate that we find, and the sine of the radian measure is the same as the y coordinate. So what that allows us to do then is take this thought of how x and y, talking about my coordinates now, my x coordinate and my y coordinate change as I go around the circle, and that is what this graph does down here. And so this is my cosine and sine graph. So let's draw cosine first. So when my radian measure is 0, my cosine is 1. So I'm going to put a dot at 1 there, because my x coordinate when my radian measure is 0 is 1, x coordinate. And then what happens is it starts to get less, right? 1 is the biggest it ever gets, and then as I go counterclockwise, it becomes closer and closer to 0 until at pi over 2, it is 0. So I'll put a dot at 0 there. And then as I continue on, we'll just continue going positive around the circle. Okay, it goes from, x coordinate goes from being 0, and then when I'm at pi, my x coordinate is at -1. So at pi, I'm going to go down to -1 here, right there. And then I'm going to continue around down to 3 pi over 2. It goes back up. It starts to get more positive again. 3 over 2, it's 0. And then finally, when I'm all the way back around the circle and back where I started, so again, the period of the cosine function is 2 pi, because it takes a trip all the way around the circle. And so then if we kind of connect the dots here as best I can, you guys can see that this shapes out what, in general, our cosine function looks like. So there is the cosine of x, x being my radian measure. So now let's look at what sine does. So sine is our y coordinate. So I'll just start out, I'll circle it, I have purple now instead of orange, so I'll circle where we're starting. Again at 0 radians, and my y coordinate there is 0. So here's my sine of 0 is 0. And again, we're moving up. All of a sudden our y coordinate starts to get bigger. At pi over 6, it's 1/2. Pi over 4, it's square root of 2 over 2. And all the way up at pi over 2, it's equal to 1. So you can see this starts to rise. And then as we go, it maxes out at pi over 2, and then it starts to get smaller again, down to pi, where it's 0. My y coordinate is 0. Continuing on, so there was the coordinate I just plotted, and here's the one I plotted earlier. Now going around down to 3 pi over 2, I have -1. That's where it bottoms out or gets to be the least, at 3 pi over 2, so I'm going to put a point down there. And then again, it starts to increase, and eventually the y coordinate gets back to 0 when I'm at 2 pi. And so we see this is also periodic, because it does the same thing over and over again. And here is a graph of the sine function. So again, the purple is the graph of our sine function, sine of x. And both these x's, guys, are radians. Our input is the radian measure, and what we get out is an x coordinate and a y coordinate around the unit circle, and eventually it traces out both of these functions. So hopefully this helps you see how we can kind of put both the unit circle and the graphs of sine and cosine together, and how we see the many patterns that are involved in both of those.